So it says, if a function denotes, if f of x denotes a function, does anyone know what notation means the inverse? If f of x is the function, how we say the inverse, you just say f to the negative 1. Boop, boop. And then if we want to say of x, we just say of x. We put that x in parentheses. That means inverse. F of x, they use f, I think, because f means function. But the inverse might not necessarily be a function. Might not be a function. To graph a function, and then to graph the inverse, you just switch the x and the y coordinates. Switch, I think switch is a good word. Flip them, whichever. And then inverses are always symmetric to what line? Does anyone remember? Inverses always reflect over y equals x. That's it. And y equals x, just as a reminder, is this line here. Just like starts at the origin, has a slope of 1. But we don't have to draw that in. We'll get to it. Okay, so when I say, hey, go graph this function and its inverse, let's just start with this good old function. We know how to graph these now. So absolute value is the v, right? What's this v doing? It is shifting. Nothing else is in the absolute value bar. So we're going to go up 3. We're going to reflect it over the x-axis, so it'll be opening down, very good. And then it'll be wider. So you guys, we're going to go up 3. And then we're going to be opening down, and it's going to be wider. And how we do that, you guys, we would just do, instead of down 1 over 1, we're going to go down 1 over 2, because my slope is 1/2 on this. And again, we're going to have all equal signs today, no shading. So there's my function. So you guys, here's what I think the easiest way to graph an inverse is. Let's go label these points. Like, what's this coordinate here? 0, 3. Very good. I was thinking 4, but you're right. It's 0, 3. And then what's this point here? 2, 2. And then this point here? 4, 1. And then this one over here? Negative 2, 2. And then finally, negative 4, 1. Here we go. You guys, what I set up here is if we're trying to graph the inverse, all you got to do is switch the x and the y coordinates. So if this point was 0, 3 on the function, the inverse has the point 3, 0. You got it. If the function had the point 2, 2, the inverse will have the point 2, 2. 4, 1 turns into 1, 4. Negative 2, 2, Ben, stick with me, turns into 2, negative 2. And negative 4, 1 turns into 1, negative 4. I would always just take those points, flip them, then I'm just going to graph those new points. So now I'm going to go graph 3, 0, boom. 2, 2 happens to be the same point. 1, 4, 2, negative 2, and 1, negative 4. And then bada bing, bada boom, I've got my inverse graphed. And then again, what Steph had told us, the graphs reflect over this line y equals x. Steph, this line y equals x is here. Does it look like my red line function was reflected over that line to land on my blue line? Yeah. Yeah. Is the inverse a function? Is my blue graph a function? Why or why not, do you think?
No.
Correct. Why is it not a function? Nice. It does not pass the vertical line test. Vertical line would go through it twice. It does not pass. I didn't leave a very big blank right there. It doesn't pass the vertical line test. You guys, here's what I would say on this one. It says, hey, go find the inverse and then go graph both the original and the inverse. Here we go. To find the inverse, you guys, just like we did right here, just like we did here, you took the x and the y's and you switched them. We do the exact same thing down here. Do you guys agree f of x is just fancy for y? So my original was y equals x plus 3 squared minus 5. True it, Garris? Then to find the inverse, you just switch your x and your y. And then we gotta go solve for y. Let's go get my y by itself. So I'm going to add 5 to both sides. Then what would we do? Yeah. When you square root, what's the square root of 4? And? Yeah, it's 2 and negative 2, right? So when I square root, we got to have a plus and a minus. We got to just remember that it's going to always be plus or minus. And then I'm going to end with, by subtracting 3, negative 3 plus or minus that square root of x plus 5. Or you could always throw that in the back, and you could say plus or minus the square root of x plus 5. I don't know why I wrote 4. And then minus that 3. These are equivalent. Either of these are a great final answer. That or that. Okay, so what I would do, though, for the graphs, you guys don't know what this graph is going to look like by hand. The plus or minus, I think it's going to be harder. Let's go graph our original, then we'll take each point and flip it. What does this original shape look like? It's the U. Which way is this U going? Left 3? Down 5. You guys, let's all go left 3, down 5. That took care of my 3 and my 5. So all we have to graph now is that x squared. And we do want to graph this accurately. Our points are really important on this. So if this x squared is our new origin, what's 1 squared? 1 squared is 1. Negative 1 squared is 1. Like we're just graphing a typical x squared graph. 2 squared is 4. Negative 2 squared is 4. So when I'm having you do these inverses, you won't have to make them skinnier and wider for the squareds and the cubes because we don't know our new points, and that's okay. This is my original. They want us to graph the inverse. If I were you, I would just go for my original's points and flip them. What point was this one? This original function at the point 1, 2, 3, 4, 5, negative 1. So what would its inverse point be? Negative 1, negative 5. I'm going to put mine in blue. Boom. 1, 2, 3, 4, 5. This one had the point negative 1, 2, 3, 4, negative 1, 2, 3, 4. So they both share that point again. Negative 4 turns into negative 4, negative 4. This one was negative 1, 2, negative 3, negative 1, 2, 3, 4, 5. Negative 3, negative 5 would turn into negative 5, negative 3. Negative 2, negative 4 would turn into negative 4, negative 2. And then this last point was negative 1, and that will flip to negative 1, negative 1. Then can we connect them? And do we have a little parabola on its side? Yeah. Find the inverse of this guy. So again, that first step every single time. What was our first step on the last problem? What do you do with your x and your y? Flip them. So instead of writing y equals, I'm going to say x equals 2 plus y minus 1 cubed. And then we got to get y by itself. So Thomas, maybe you write yourself a little note. 1, flip the x and the y. 2, get y by itself. How would I get y by itself here? I'm going to subtract 2 first. Then we're going to cube root. Good question. Do we have to do plus or minus? We don't. Any odd function, we don't have to do plus or minus. And here's why. I'm going to give you the y. Let's get my y by itself, and then I'm going to tell you why it does not need to be plus or minus. What would be my y equals? Cube root of x minus 2. What would we do with that minus 1 to get it over there? Love it. Okay. And then we're wondering, like, why do we not have to do a plus or minus here? So when I say, what is the square root of 4? What's our answer? Or, right? Plus or minus 2, right? If I say what's the cube root of 8, what times itself 3 times gets me 8? Only 2, correct? What is the cube root of negative 8? So there is only one answer on cube roots, because if this was a negative 2 times a negative 2 is a 4, times a negative 2 would get me a negative 8. But when there are two answers, I've got to do the options. So anytime it's an even exponent, we have to do a plus or minus. Odd exponent is just whatever was already there.
Okay.
Sound good? Okay, so then let's go graph our original. Thomas, I think it's easier to graph the inverse from the original. I think it'll be harder to graph this. So let's go graph my original. What's this shape look like? X cubed, right? Where's that x cubed going? 1 to the right and then up 2. 1 to the right, up 2. Boom. It's x cubed. I'm not making you make things skinnier or fatter on this, you guys. So if this is my new origin, what's 1 cubed? 1. What is negative 1 cubed? Yeah, negative times a negative times a negative is a negative. I don't have space for 2 cubed is 8, but I do have space for negative 2 cubed is negative 1, 2, 3, 4, 5, 6, 7, 8. It's just off my graph. I'm going to put it down here. So that's my original. That's my original. And then to graph the inverse, because they asked for graphing both the function and the inverse, I would just take these points, Thomas, and flip them. If we had the point 0, 1, what does that new point turn into? 1, 0. We had the point 1, 2, so now it's 2, 1. We had the point 2, 3, so now that's 3, 2. And we had the point negative 1, 2, 3, 4, 5, 6. That would turn into negative 6, negative 1. Does that sound right? That was negative 1, negative 6. So its corresponding point would be negative 6, negative 1. Then I'm going to connect them. And it goes a little something like this. Woo! And that's a cube root graph. So that makes sense. And it looks like it's reflected over that diagonal line y equals x.